Good evening, everyone. We are the second group for Project 5 Customer Analysis. In our project, we specifically focused on the customer complaints analysis. Firstly, I will briefly introduce our project, and then every teammate will introduce their own part. The data we derived from the Consumer Financial Protect Bureau website. This organization collects the consumers' complaints about the financial product and the service, and we restricted our data scope so that we have about 370,000 records in our dataset. And in this analysis, we mainly use several fields like product to identify what the complaint is about, and the narrative, which refers to consumer's description, and which company, which stats the complaint reads from. In summary, our project aimed to conduct several network analysis to understand the financial marketplace issue and cautionary notice to companies and product customers. And there are some visualizations of our data, and more details will show in our report. Okay, let's move to my own part. In this part, the objective is to identify the key information about complaints regarding each product. For the methodology, I firstly tokenized and lemmatized the consumer complaints narrative by the NLTK library in Python. And second, I set notes to present the words, ages to present the co-occurrence of two words within a same narrative, and the weight to present the frequency of two words co-occurrence. And last, I also identified the key influencer by the weighted degrees centrality. As a result, we can generate several networks. There, just take a project students' loan as an example. The green notes are the key influencers. They refer to the narrative like the student's loan, is my payment back, and etc. And while I also highlighted some product-specific words with green, we can see they are exactly some service for students' loan. So after this, we can have a direct and quick insights about what's the main topics the customers complaints or what are the companies should pay attention to. Okay, my teammates will introduce the following analysis.
Let me introduce the third part to you, company responses analysis. The main objective is to identify how communities of companies with similar product issues respond to customer compliance. The methodology I applied is first, community detection. I applied the Loven community detection algorithm to identify distinct communities within the network. The second is attribute analysis. I performed attributes analysis within each community. First step, I created the network. I constructed an undirected graph to represent the relationships between companies based on their shared products. Each company is represented as a node, and if two companies share a product, an edge is added between them. Companies within a community may receive similar types of consumer compliance or feedback, indicating common issues faced by consumers regarding the products offered by these companies. For the node attributes, I used company responses to consumer compliance and the timely response rate. This can help to identify if there are some common groups of companies within a particular field and how they handle customer compliance. Here's the analysis result. The company can be divided into three communities according to the main products compliant about. Each community may represent a unique market segment or industry. Communities vary in the types of products they offer and their customer base. On the other hand, it may also be that companies in each community have different product structure weaknesses, which lead to compliance from customers. For example, the community 0, they may have problem in credit service. The community 1, they may have problem in mortgage and financial services. For community 2, the customers may be compliant about their debt collection and credit services. Companies in different communities also employ different strategies for responding to customer compliance. The experimental results show that there are significant differences in the responses of different communities to customer compliance. Community 0 mainly responded in the way of closed with explanation, and almost all of them responded in a timely manner. Community 1 chose closed with explanation and closed with non-mandatory relief more often, and almost all responded in a timely manner. Community 2 mainly adopts closed with explanation, but the timely response rate is lower than two communities. That's all for part 3.
The next part is about the company problem analysis, which mainly investigates the patterns and identify major pain points within each community. About the community detection, applied Leiden algorithm, and then a priori is utilized for frequent item citing mining and association rule learning. About the network construction, firstly, I create a new file named problem, which is a combination of the subproduct and issue files to capture the specific complaint, and then calculating the shared complaints for understanding the similarity between companies. And next, the iGraph is used for constructing the network. And the nodes represent companies, and edge represent they have shared complaints, and the weight of each edge corresponds to the number of shared complaints. And about the node attributes, it includes the state of the company and the total number of complaints for the company. And for community detection results, we can see the same number of communities compared with Loving algorithm, and it's 4 communities. And it's noticed that the Leiden has the faster running speed with the larger data set. And from the basic statistic analysis, we can see community 3 had the highest number of complaints and types of issues complained about, and it has a relatively small number of companies. And then association rules are explored. The top 10 rules for each community were found based on John's metric, along with the support, confidence, and Lipton matrix. And to facilitate visualization, the problem ID of each rule is represented in the network graph, and the association rules found are shown in the above figures. It is noticed that in community 1, problem ID 3 and 7 played an important role and tend to correlate with more other issues, such as debt collection or the credit problem. Especially for community 2, it responds to a more dispersed set of complaints issue with a reduced threshold, and only 6 rules are identified. And for community 3, problem 5 refers a credit reporting company's investigation into an existing problem, and it mainly arises issues with incorrect information and improper use of the credit report. And for community 4, problem 4 is about the student law, and it tends to relate it with the credit reporting, incorrect information. And the more details I will display in our report. And for the time trends, we can see the community 3 has had a much higher number of complaints over the past year, and all communities have seen a significant decrease in the number from May this year to date. And for the state distribution, complaint issues in all 4 communities are centered in certain states. And this is about the part.
The next part is for the company early warning, which means we need to identify a product that a company may have complied with in the future. Our methodology mainly uses node-to vector model and link prediction. The step 1 is to create a bipartite graph. One partition is company, the other partition is products. If there are complaints of company A about product B, then we connect A and B. Step 2 is to split the dataset into training and testing sets. We use 75% company as training data and 25% company as testing data. The step 3 is to find the most similar company in training data for each company in testing data. We combine 3 similarity measures, including common neighbor, job card coefficient, and research allocation index. Step 4 is to train the node-to vector model on training set. We set the number of work 15 and set work length 10. Finally, we recommend product to the company in testing data based on the company in training data. Here is our analyst result. From the result, we can see that the first column is testing company, and the similar chain company is calculated by similarity measure. Scores is the node similarity between chain company and products based on the node-to vector model, and we recommend the top 3 products to the test company.
In this section, we will proceed with customer information flow analysis. We try to analyze the spreading of information among customers and identify the influencers in the network to enhance customer experience and decision-making in the banking sector. The methodology employed is the independent cascade model, which simulates information diffusion in the network and allows nodes to influence their neighbors with a certain probability at each time step. In the simulation, we selected 100 data points to demonstrate the customer information flow.
Each node represents a customer identified by their complaint ID. To create edges between nodes, we consider two nodes sharing at least 4 common attributes among product, subproduct, issue, sub-issue, company, and state. Nodes initially affected with the information are shown in white. Susceptible nodes in blue, and nodes informed during the simulation in orange. As the simulation progresses to t=5, almost all customers are affected, except for two who are informed. Now, let's identify the top influencers in the network based on different centrality measures. The table above displays the respective centrality scores for each customer. These influencers play a critical role in spreading information across the network and influencing the behavior of other customers. That is all of our presentation, and thank you for listening.